We got a good one for you today, guys. A full Kodiak 900 walk around. Let's do this. What's up, everyone? Mark Brown here with 11 Aviation, here in front of this Kodiak 900. I'm really excited about today's video. This is going to be a full, in-depth Kodiak 900 walk around. This is going to be filmed over a handful of sessions with a couple different airplanes, so we'll cut as things are filmed, but I'm going to give you all the details and the history and everything about the Kodiak 900 that you might need to know or might have been wondering. And guys, if you don't mind, if you're interested in this content, please subscribe to this channel. It really helps us out. We can continue making this great content for you guys. And please, if you have any questions about the Kodiak 900 that we don't go through in this walk around, comment below. We'll make a second video or a follow-up video. We're also excited. We just launched our 11 Aviation website. It's the Kodiak Owners Group sign up. So whether you're a Kodiak owner or you're just interested in Kodiaks, go ahead, go to 11-aviation.com and put in your information. You'll get all the event info for Kodiak owners flyouts and other cool Kodiak stuff that we're going to be doing in the future. And last, I want to say thank you to this client. He has been so gracious in letting us utilize and film his new Kodiak 900. He is a client that has been with us. He used our acquisition services and our management services. We're going to help him manage this airplane. He's a brand new turbine owner, and we're going to help make that process a lot more streamlined for him. So thank you to him. And if you guys are interested in Kodiak management, single engine turboprop management, or acquisition or training services, please reach out. Contact details are below. So starting with this walk around, the Kodiak 900 has this 97-inch 5-blade Hartzell composite prop. This has 15 inches of prop clearance, which you'll notice is a little bit less than the Kodiak 100. And the Kodiak 100 is all about being a bush plane. It's designed to go everywhere. Kodiak 900 doesn't have all of those capabilities. So everything in this airplane is really designed as a compromise between some bush heritage, but also geared more for speed, comfort, luxury, utility. So this propeller has the 15 inches of prop clearance, but what's unique about this prop is it's a 1900 RPM. So not only is that easier to fly, because once that prop lever is all the way forward, you never really have to touch it again through a normal flight until shutdown. But what it's also nice is it's less than 80 decibels of noise. So the slower rotating prop means that this airplane can operate anywhere in the world. It's got less than 80 decibels. It's actually about 79.5. So this is a very quiet airplane respective to its 900 horsepower, meaning it can go anywhere and it meets the strictest noise regulations anywhere on the planet currently here in 2024. So behind this 97-inch prop, you'll notice this new air intake. So obviously one of the major differences between the Kodiak 100 and Kodiak 900 is the firewall forward. The airplanes are essentially very, very different. One of the main differences is this new air intake. The Kodiak engineers spent a lot of time trying to get this just right, not only for airflow at cruise flight, but also airflow during start. So the Kodiak 900 is engineered to be able to do multiple battery starts per hour, maintaining low starting temperatures. So for high cycle operators like skydive operators or special operations operators, they can do multiple starts per hour. They don't need a GPU. They don't need to wait a long period of time for the engine to cool down. Additionally, this has the same style of inertial separator that the Kodiak 100 has. The Kodiak 100 has an electronic inertial separator. This is also the same. So all you have to do is flip a simple switch in the cabin if you're going into icing conditions or if you're going off airport, and you've got the same style inertial separator in this air intake. You also see a couple of the main differences from the Kodiak 100 and 900 are these oil NACA ducts. So this is the oil cooler NACA duct. It's split into two. The Kodiak 100 just has one NACA duct on the pilot side for the oil cooler. Kodiak 900 has these two. And then over here on the co-pilot side, you'll see that there's another NACA scoop, and that's for things like air intake for environmental control systems. So this propeller also has these leading edge boots. Now, this isn't the same style of boot you might think of as like a heated prop. This is the same style system as the Kodiak 100 for anti-ice. So the anti-ice system on this prop is what's called a TKS slinger ring. So right here you have the TKS that weeps out, and these are channels that the TKS then runs down to wick ice off the propeller during icing conditions. So next we'll talk about one of the major differences between the Kodiak 100 and 900, and that's going to be the nose gear, specifically the wheel pants on the nose gear. So it's a fixed gear system. The nose gear is a oleo style strut with both nose wheel steering and a free castering nose wheel. So the nose wheel steering is about 17 degrees of center, and it free casters to about 55 degrees of center. Why that matters is if you're on a very short, narrow strip and you have to make a 180 within the confines of the strip, this nose gear can do it the same way as the Kodiak 100 can. One thing you'll notice is you've got this big aerodynamic wheel fairing or wheel pant on the nose gear. This is vital in helping the aircraft maintain and get to that 210 knot true airspeed. A few things to note about the Kodiak 900. Having flown it now quite a few hundred hours for the last 2 years, one thing that I've noticed quite a bit is a lot of FBOs have trouble towing the Kodiak 900. This is probably one of the largest airplanes with a nose wheel fairing. And so there's a couple things that we generally recommend in our training to our clients. Kodiak gives you a really nice cover to protect the paint. So if they do tow the airplane, they're not messing up the paint on this nose gear. Additionally, you have some tow hook extenders. There are some tugs that can't get into this little small space on these tow hooks. So that's something to be mindful of. Additionally, if they have the style tug where it comes up under the nose gear and cinches down, those really aren't usable because it could damage this forward composite section. So towing the Kodiak 900, in my experience, has definitely been a learning curve. Of course, the more of them that get out there, the more FBOs will have the necessary capabilities to tow these, but that's something to be mindful of. On the other side, there is a little door that you can easily open to both check tire pressure and refill tire pressure. Additionally, if you do ever run into a problem at an FBO where they can't tow the airplane, this forward part of the nose fairing is actually really quite easy to get off. It's a handful of screws. It's obviously not ideal, but if you are in a pinch, they can take this off and tow it like any other nose gear airplane. One of the largest changes from the Kodiak 100 to the Kodiak 900 was the engine. The engine makes a huge difference between the two airplanes, and of course everything connected basically firewall forward is very different between the two airplanes. So the Kodiak 900 is powered by a PT6-140A engine. It's the largest of the small PT6s that Pratt makes. So this PT6-140A is a 900 horsepower continuous engine, meaning it makes 900 horsepower for both takeoff and cruise flight. It has two independent turbines like most PT6s. It's got one for the compressor gas generator section, one for the propeller section. This -140A has a newly designed reduction gearbox in it. Additionally, this engine has a sight glass for the oil, which is different from the Kodiak 100. It carries 14 quarts of oil. It also has a designated borescope access port for easier maintenance. And last, the engine has a 4,000 hour TBO with a 2,000 hour hot section inspection, which matches the Kodiak 100's TBO and hot section. Another new component is this 13-member steel truss frame for the engine mount. Additionally, in the Kodiak 900, the Kodiak team relocated the MCU box in the batteries. And so what that essentially amounts to is a lot more room in this Kodiak 900 engine bay, with mechanics really liking that. One of the major components for the Kodiak 900 was about not only making a new airplane that went faster, that had more refinement for both the pilot and the passengers, but mechanics were also really thought about during the process. And having an engine compartment with no batteries and the MCU box being relocated just gives mechanics a lot more room to access things in this engine bay, making things quicker and easier, which if you're a fleet operator or a special missions operator, can really translate into cost savings because it's quicker and easier to do maintenance on the Kodiak 900. A couple other things that are different in this Kodiak 900 versus the Kodiak 100 is Kodiak's team did some additive manufacturing, essentially 3D printing during the design process. So things like the alternator shroud and a few other things have sort of new technology, less complex components. So that benefits the Kodiak 900, less complexity because of new advancements in manufacturing technology. This is your AC system. So it's still an engine-driven compressor for the what's called the VCS, vapor cycle system, or air conditioning system. So that's still right here. You still have that. It's belt-driven off the accessory gear case. We talked about the sight glass for the oil. You've got a standby 60 amp alternator, which will power the essentials for the airplane if you have your main electrical source go down, which is your 300 amp starter generator. You also see here the oil cooler is down here. Having redesigned the bottom of the cargo pod gave Kodiak's team a lot more engine bay to work with. On the Kodiak 100, this is all sort of wasted space on that forward firewall fairing, where now this is all part of the engine bay, just giving a lot more room for everything. The oil cooler is split into two. One section is sort of right here, the other section's on the other side. What a lot of folks don't realize is cleaning up the outside of the airplane aerodynamically is one component of making an airplane go faster. Another major component is actually the airflow that comes through this air intake. How it goes through the engine and how it exits can be a major source of drag. So if you look at a lot of the Reno air racers, they spend just as much time doing things inside the engine as they do doing things outside aerodynamically. The Kodiak team is no exception. They redesigned and re-engineered all the outlet ducts for both the oil cooler, for both the inertial separator bypass ducts. Those are all designed to be very aerodynamic, allowing them to flow nicely along the edge of the airplane and not come out and create turbulent airflow that would then slow the airplane down. We also have the same sight glass for the 5606 brake fluid, which is nice, easy to read. You can easily tell as a pilot, I got my brake fluid. You can also see trends. Is this lowering? Do I have a small brake leak somewhere? That's what I like about it as a pilot. You can really easily see trends by just a quick glance. You also notice here, we'll talk about this in a minute, but this is the TKS box. This is now the new filler station for the TKS tank. It's up here in the firewall. You've got your same GPU hookup right here. So if you wanted to do ground power, this is your ground power unit. And last but not least, you've got new exhaust stacks that go with this Kodiak 900. Same look as the Kodiak 100. They come out the side, go down the side of the airplane a little bit away from it. But these are, again, designed specifically for the Kodiak 900. So you might think, doors, what is there to redesign about airplane doors? Well, the Kodiak 900 has a completely new style crew door on both sides. Couple things that were added that I particularly love as a pilot of a Kodiak 900 is, first and foremost, they added this magnetic latch to it, which is awesome. So when you open this door, it now swings a full 180 and latches magnetically. So nice. And then it's easy then to bring forward to a close. Really clean, really simple, zero complexity. That magnet just stays right here below this placard. Same style door hinge, close it, latches like that, open, brings it up like that. Additionally, something else that was done, this was sort of actually fixing, frankly, a little bit of a problem with the Kodiak aircraft, is the crew door windows. So the way these crew door windows are now affixed is a much cleaner and a better solution. The Kodiaks, the 100 specifically, the older models, had a little bit of a problem with crew door window cracking. And essentially what my understanding is that it's because the windows don't have enough room to expand and contract with the heat and the cool. and that causes some splintering and can also cause some cracking. And these newer Kodiak 900 style windows do have that room to expand and contract, so they shouldn't have that same problem. A few things on the inside of the door that have been changed that I really love is you still have the cup holder on both sides. You still have the inflatable door seals, which keep the noise and the airflow out of the cabin when these inflate. But you also now have this new armrest. This new armrest is a really great addition. Started here in the Kodiak 900, as we talked about in the Series 3 video, which I'll link below. These are now incorporated in the newer style Kodiak 100s as well. So a couple major changes that really make this new door a lot more pilot friendly, but also should be better from a maintenance and reliability standpoint as well. Another nice thing about every Kodiak 900 is they all come standard equipped with the single point refueling system. So this is the same single point system that the Kodiak 100 has had for a number of years. But what Kodiak, the manufacturer, decided to do was make all of the Kodiak 900s come standard equipped with the single point system. Certainly makes it a lot easier than having to crawl up on this high wing and refill. Overwing, of course, you do still have that option. So if you are filling at an airport that doesn't have a single point hookup, you can certainly fill overwing. The wing tanks are the same sort of style and size for the most part as the Kodiak 100, 320 some odd gallons, 320, 322. But this single point system's nice. It's all pretty automated. You can fill it up. It'll automatically stop when it's full, or you can fill one side or the other, but it's all pretty easy to operate. My favorite two things about it: when you're done using it, it hides real nicely in the wing. There's nothing sticking out causing aerodynamic drag, and it's also a very lightweight system. I think the whole single point system weighs something like less than 20 pounds if memory serves correctly, so it doesn't add a lot of weight to the airplane. The great thing for both a fleet operator or an owner or anybody that has both Kodiak 100s and Kodiak 900s is your mechanics will pretty easily be able to switch between the two airplanes because there is a lot of part similarity. So this main Kodiak wing is essentially the same between the 100 and the 900. I'll point out a few of the differences that you can note that the Kodiak is a Kodiak 900. The major one being these flap track fairings. So it's the same huge flap that's on the Kodiak 100, but now you've got these fairings that have this cool sort of tapering end to them that I really like. I think it just makes the airplane look fast, but they do help somewhat aerodynamically, and it's the easiest way to tell the difference between the Kodiak 100 and Kodiak 900 when looking just at the wing. So you have the same 35-degree flaps, you have the same ailerons, you have the same style wing with this discontinuous leading edge. So as we all know, the Kodiak 100 is well known for its stall characteristics. The fact that it really doesn't stall, it's really quite impossible to spin. So the Kodiak 900 shares that same wing, very, very difficult to stall and almost impossible to spin because this outboard section of the wing never loses lift. A couple things you'll notice on the wing, right here is the overpressure valve for the single point system. So it's hard to see because it's black on a very, very dark colored airplane. But essentially the way the single point system works is if for some odd reason their fuelers are fueling the wing and it overpressurizes, these blowout valves are designed to blow out before anything in your airplane gets damaged. So it's basically just a spring-loaded valve. If you overpressure the tanks, it pops down, fuel goes everywhere, but it saves your airplane from getting damaged. And then once the pressure is released, it just goes back up, seats back up into that inspection panel. Same sort of discontinuous leading edge, same sort of stall vane, heated with TKS. We'll talk about the TKS here in a little bit. You have the same pitot mast, so it's essentially the same exact pitot mast static system. You have one on both sides. The Kodiak 900 is the same as the 100 in the sense that it has two fully independent pitot static systems. Right here you see a placard. It's the magnetometer, so of course it's a Garmin system. So you have the Garmin magnetometer right here that runs the compass system. Out on the outboard section of the wing, you have the same style taxi and landing lights. So you have an LED taxi pulse light and you have an HID landing light on these early Kodiak 900s. And then of course you have the LED strobe and nav lights on the wingtip. You have the 2 static ports per aileron, 2 here on the pilot side, 2 on the co-pilot side. You've got your electronic aileron trim, which I love. The Kodiak 100 also has this. Kodiak 900 shares it. All 3 trims are electric. There's no old school manual trim wheels, although you can choose on the elevator trim if you want to use the manual trim wheel, but you can do it electronically as well. But the aileron trim is here on the pilot side. So a lot of things very similar from the Kodiak 900, the flap tracks being the main difference. You also have the strutted wing, so you've got the main gear struts here, and then you've also got the single point system, and you still have the fuel magnetic dipstick, although with the single point, I find myself using that a lot less because I can easily check my fuel load with that single point system. Probably the biggest and easiest way to tell a Kodiak 100 and a Kodiak 900 apart is the Kodiak 900 has these big main gear wheel fairings, also known as wheel pants. So these, a lot of people have very strong opinions about, but at the end of the day, these are a huge component to the true airspeed of 210 knots this Kodiak 900 gets. These have had a lot of testing done from the manufacturer. When I was at the manufacturer, these were a large component of the aerodynamic testing that was done. In fact, just small changes of as little as 2 inches one direction or the other was the difference between something like 5 knots. So these are very, very highly integrated from an aerodynamic function with the Kodiak 900. But what I personally really like about the wheel fairings is a lot of people think of wheel fairings as being quite flimsy, if you will. And that's because most manufacturers actually certify wheel fairings as non-structural. And essentially all that means is during the FAA certification testing, a non-structural component just has to stay on the airplane during dive tests. The wheel fairings on the Kodiak 900, the manufacturer actually certified these to what's called secondary structure. So essentially these have to go through the same sort of structural component testing as things like the cargo pod. And so what that allows me to do with these wheel fairings, just to showcase the strength of them, is I can easily stand on them without any issue whatsoever. These do not take away the performance and off-airport capability of the Kodiak 900. These are extremely robust wheel fairings. Now, one of the major differences beneath the wheel fairings is the wheels and the wheel size. So having quite a few hundred hours flying the Kodiak 900 specifically now, one thing I've really learned that sets the 900 apart from the 100 is its soft field capability. One of the big differences with these tires from the Kodiak 100 is these are a much smaller, higher pressure tire. So it's almost double the PSI of the Kodiak 100. The Kodiak 100 also, the Series 3s at least, comes standard with a big balloon 29-inch low pressure tire. A couple factors that make the 900 less suitable for soft field landings is going to be a couple things. Number one, this is a heavier airplane. This airplane weighs 8,000 pounds max takeoff weight versus 7,255. You've got a smaller footprint for a tire. You've also got a tire on the 900 that's double the PSI. So what all that boils down to is this airplane has a tendency to want to sink on soft fields a little bit more than the 100. The 100 you can land on muddy strips. I've landed in snow before. I've landed in strips that were flooded. Don't recommend it, but it's possible theoretically depending on factors and situations. Kodiak 900, I'm a lot more cautious going into softer field airports. Now, I say all that, and it's all respective on the fact that the Kodiak 100 is such an amazing backcountry airplane This can still do more than pretty much any other airplane. It's just compared to the 100, this doesn't do soft fields as well. So if you're planning on going into really soft airstrips, the Kodiak 900 might be something to consider not being the best airplane versus the Kodiak 100. But again, it's all about your mission. It's all about where you're going. If you guys have questions about can the Kodiak 900 operate in and out of my strip, please feel free to reach out. We're always happy to consult and go through those scenarios with you. So not only did the Kodiak team spend a lot of time changing and making the wheel fairings aerodynamic, they spent a lot of time on the landing gear fairings as well. So all of these are very different from the Kodiak 100. These were all made to be as aerodynamic, as sleek, as well-fitting as possible, specific to this airplane. And you can really tell there's no brakes in this main gear fairing. There's no brakes. This is a really nice fitting landing gear strut fairing. You even have little VGs right here that all help with just keeping that airflow attached and preventing it from becoming turbulent and increasing the drag. Now, something else that's been done, and it's a little bit hard to see with this landing gear fairing being on top of the landing gear itself. The landing gear is very similar to the Kodiak 100. It's a fixed style landing gear with no hydraulics, no springs, no struts, etc., which makes it, again, extremely robust. One of the big differences, though, in the gear from the 900 to the 100 is it's moved down and it's moved aft. So you'll notice that if you look at a profile view between the two airplanes, the Kodiak 100 sits a little bit tail low and nose high. The Kodiak 900 sits pretty even with the ground. Basically, the nose to the tail is parallel to the ground. And that's really predicated on the gear being a couple inches further aft. And the Kodiak 900 sits much, much higher than the 100. And that's because the gear was moved down a handful of inches. If you were actually to take this gear off, you'd see that the gear on the 900 actually, the carry-through tubes and the trunnions that hold that all together are actually attached below the main fuselage floor. In the 100, they actually go through the fuselage floor. So it's actually a little bit easier to work on the Kodiak 900 gear because the main gear itself is not through the floor, it's actually below the floor. How is that accomplished? Well, the cargo pod being an integral part of the Kodiak 900, they were able to have that room because every 900 will have this pod. Now you can move the gear down and it's not a problem at all. The gear was moved 5 inches further down than the 100. So a couple byproducts of that movement is internally the cable system. So the Kodiak product line is all controlled via cables and pulleys. The cables that run from the front yoke to the aft portion of the airplane now don't have to go up and around and through the landing gear. It actually makes those runs a lot straighter, which decreases complexity and decreases maintenance costs. So that's better for everybody. Additionally, moving the gear 4 inches back changed the need for a tail stand. So a lot of questions that we get as Kodiak experts is why the Kodiak 100 needs a tail stand. Well, a lot of airplanes use tail stands, but the fact of the matter is the Kodiak 900 actually really never needs to use a tail stand. There might be some cases where if you're putting something super, super heavy, like 1,000 pounds in that back door from a cargo standpoint, maybe you'd want to use that tail stand. But for general loading and unloading, the Kodiak 900 really never needs the use of a tail stand. So how does this all affect the takeoff roll and the takeoff characteristics of the airplane? And if this is so much better, why doesn't Kodiak do that on the Kodiak 100? Well, you know, with everything in airplanes, it's always a compromise. So by moving the gear aft, you change the characteristics for both takeoff as well as the length of the takeoff. The Kodiak 900 being less of a STOL airplane than the Kodiak 100, this was a compromise the manufacturer was willing to make. The 900, even though it has more power and actually a better power to weight ratio, it requires slightly longer runway than the Kodiak 900, A lot of that has to do with where that gear is placed. So a lot of major changes between the Kodiak 100 to the Kodiak 900 on gear placement and gear aerodynamics, but the actual innards and foundation, the gear is very, very similar. Steel trunnion, 2 carry-throughs, and a tapering straight tube from the trunnions down to the main gear. A question that I get a lot is, how do these wheel pants or wheel fairings affect general maintenance from a pilot standpoint, as well as braking, etc.? So the Kodiak team's thought of most of that. They have this gear door here, which is easy for me to be able to check air pressure in the tires and refill air in the tires. Additionally, you can take these wheel fairings off, so you can fly the Kodiak 900 without the wheel fairings. These are the only tires right now that are certified for the airplane, so I don't know why you'd want to take them off, but maybe there's a reason. Additionally, the brakes. The brakes are very similar to the brakes on the Kodiak 100. The difference being that this is a heavier airplane. This airplane also rolls better because it's got smaller, higher pressure tires. So the rolling friction of the Kodiak 900 is a lot less than the rolling friction of the 100. The 100 has those big sort of balloon tires. Those create a lot of rolling friction. So that actually helps your stop for your short takeoff and landing distance, where this airplane rolls a lot better, so you need more brakes to help it stop. So the brakes are a similar size, and they also are shrouded in this wheel fairing. So in my experience flying this airplane so far, the brakes can get hot during training, but it hasn't been any issue for normal operations coming to a stop, etc. But I do encourage taxiing using the throttle as speed control. So we taxi generally on straightaways with more throttle control than brakes. You really don't want to ride these brakes. If you're going to use them, you really want to use them. But overall, this landing gear system on the Kodiak 900, in my couple years of experience flying this airplane, has been really impressive.